Hello. Um, I hope that everybody has been keeping up with all the videos and all the homework. So today, the topic of the video is the is optimization. So, how do we apply calculus in optimization problems? That is, how do we find the maximum and minimum values of a function? So, let me define a couple of terms here in general words, and then I will explain them in more detail in the next few slides. So the first two terms that I want to roughly define are absolute maximum and absolute minimum. Now we use the word global instead of the word absolute in sometimes. So we use the term absolute maximum or global maximum. Similarly, absolute minimum or global minimum. So what are they? The maximum value attained by a function on a specified domain is called the maximum value of the it's called the absolute maximum of the function on that domain. On the other hand, the minimum value attained by a function on a specified domain is the absolute minimum value of the function on that domain. And in contrast, we have local extrema or local maximum and local minimum values. And so the local minimum and local maximum and local minimum values are located at the largest or smallest y values for all nearby x. In other words, these are locally maximum or locally minimum values of f, which I'm going to explain in detail in the next few slides. The local max or local mean values, they may not represent the absolute max or the absolute min. Now, one thing I want to make clear from the get-go is that the maximum and the minimum values of the global max and global mean of a function depends on the specified domains. If we change the domain of the function, we may change the global max and global mean. So global max and global mean it is with respect to a given domain. So let's look at the following example. So here I have the graph of the function f of x, which is 12x minus x cubed. And if you look at this graph, notice the following. So if I take the domain of this function to be the set of all real numbers, which is the largest possible domain of this function. The largest possible domain of this function is the set of all real numbers. And in that case, this function does not attain a global max or nor a global mean. The reason is, notice that as x goes to infinity, the value of the function goes to negative infinity. So which means that f takes on arbitrarily large negative values. So, on the other hand, when x goes to negative infinity, the value of f goes to positive infinity. So f takes on arbitrarily large values. So as a result, f doesn't have a global max or a global mean. However, f has a local max at the point at x equals to 2, and it has a local minimum at x equal to negative 2. Now, the function f has a local minimum at negative 2 here, and the reason is you can see that there is an open interval centered at negative 2 where f of negative 2 is the lowest value of f. Once again, f of negative 2, which is negative 16, f of negative 2 is the least value of f in some open interval centered at negative 2. So that's why at negative 2 we have a local minimum. We have a local maximum at 2, so that means that f of 2 is the largest value of f in some open interval centered at 2. So let's say I pick the open interval from 1 to 3. In that interval, f of 2 is the largest value of f. So locally, it's the max value of f, locally near 2, and locally near negative 2, this is the least value of f. So this is a local min, this is a local max. Now, if we restrict the domain to, let's say, the closed interval from negative 4 to positive 4. So if we take the domain to be the interval from negative 4 to positive 4, then notice that in that on the interval from negative 4 to 4, f of 2 is the global max and f of negative 2 is the global mean. So if f of c is larger than f of x for all x in the specified domain of f, then we say that f of c is the absolute maximum or the global maximum of f on that domain. If f of c is less than f of x for all x in the domain of in the specified domain of f, then f of c is called the absolute minimum value of f in that domain. An absolute max or an absolute mean is called an absolute extremum, and the plural for extremum is extrema. Let's analyze the graph of the graph of the function f of x, which is given in red. Notice that in this case, as x goes to infinity, f of x goes to negative infinity, and also as x goes to negative infinity, f of x goes to negative infinity. So notice that f of 0, which is equal to 2, that's the global or absolute maximum of the function f on the interval from negative infinity to infinity. So here the domain we are picking is the interval from negative infinity to infinity, and in that interval f of 0 is the largest value. Now in the entire interval here, in the entire domain of f, we don't have global minimum because notice that f is becoming arbitrarily large and negative, so it doesn't attain a minimum value. So f has no absolute minimum. On the other hand, if we look at the graph in part B, notice that as x goes to infinity or as x goes to negative infinity, the value of the function goes to infinity. So that means that g of x can be made arbitrarily large. But the g of 2 is the minimum value. So g of 2 is the absolute minimum of g on the interval from negative infinity to infinity, and it has no absolute maximum. Let's consider the function f of x equal to x squared, and we are We are not taking the largest possible domain for this function. We are picking the domain to be the closed interval from -2 to 1. And this is the graph of f of x equal to x squared between -2 and 1. Now notice that in this case, the global maximum value, so the absolute maximum of f on this interval is f of -2, and the absolute minimum value is f of 0. So because f of 0 is the least value of f on this interval. And we can also say that f of 0 is the local minimum because f of 0 is the least value of f in some open interval centered at 0. So we can say that f has absolute max at f of -2, which is 4, and f has absolute minimum at 0, which is f of 0 is 0. Okay, so I'm going to stop here, and I hope that I have explained the terms absolute max and absolute mean, and local max and local mean.